Okay, sometimes when we're trying to solve a certain type of questions, if we can use certain type of method, then that question might be pretty easy. For example, to find the minimum value of y is equal to x plus 5 of x for x is greater than 0, we know this is a typical calculus 1 question where we can just go ahead and differentiate this, find the critical values, and then maybe do the first or the second derivative test, right? However, today, let's challenge ourselves not to use calculus. Can we still do this? Pause the video and try to come up with an algebra student-friendly solution for this question right here, okay? Okay, I want to show you guys two solutions. The first one is, of course, no calculus, just purely on algebra. And the second one is, of course, I will still show you guys the good old calculus solution, okay? And by the way, if somebody is asking you this question, don't show off your calculus skills unless you know he or she is actually in calculus. If it's an algebra student asking you this question, then you have to think about what the algebra solution would be, okay? So know your students, or know your audience, know your viewers and things like that. Anyway, here we go. This is just the non-calculus solution. I know how you guys are feeling. You will just want to differentiate this. But the moment you cannot differentiate this anymore, oh my God, this is like so much tougher because I think the psychology that kind of gets you too, right? So, oh, why can't I just do that? But anyway, let's go back to the fundamental. We want to find the minimum value of this, right? Okay? So just like the typical algebra things, we are just going to call the minimum value of this to be a variable, right? The number, right? So let me just use m. So I'll just say that m to be the minimum. And by the way, whenever we're talking about the minimum value, we are talking about the minimum y value, okay? So the minimum value of this, namely x plus 5 over x, okay? And what we are going to do is we want to make this equal to m, right? So let's see, we have x plus 5 over x. I want to set this equal to m, and that's the minimum value for this expression. And now what? This is an equation with fractions, right? So why don't we just do the typical things? Let's multiply everything by x. And now, we have a quadratic equation here, right? So let's move the mx to the other side. So we will have x squared minus mx plus 5 equal to 0. The graph of this part is going to be a parabola. We want the vertex of this parabola to be 0. You know this is an open up parabola. I want to have the parabola like this. And the vertex happens to be right on the x-axis. We have a vertex formula, isn't it? This right here is x equal to negative b over 2a. We don't need to use calculus to show this. We can just do completing the square right here, okay? But I'm not going to complete a square. This is just a vertex formula from your algebra class. And now let's just work this out. So let me put this down. The vertex is at x equal to negative b. So we have negative. B is negative m. So we will have negative m like this. Over 2 times a. A we know is the coefficient right here, which is 1, right? And let me just also put down c. C is equal to 5. Otherwise, c is going to get jealous. But anyway, this is negative m over 2 times 1. In another word, this is just going to be positive m over 2. This is just the x value. Don't forget to plug in this back here to get the y value. So let's do that. Y would be x squared. So I'll put this down as parentheses m over 2 squared minus m. And then this x is the m over 2. And then plus 5. Right? And the deal is we want to set the y value to be on the x-axis because once again, we subtract this, so the right hand side is equal to 0. And we want to set this equal to 0, like that, okay? Now, let's try to figure out what m should be. On the left-hand side here, this is m squared over 2 squared, which is 4. And then this is minus m times m is m squared, but this is just an over 2 on the bottom. And then this is plus 5. This is equal to 0. And I want to solve for m. And why don't we just multiply everything by 4 so that we don't have to deal with fractions? So let's do that. And you see, this is m squared minus 2m squared plus 20 equal to 4 times 0 is 0. I didn't combine terms earlier because I didn't want to get the common denominator. And now I will combine terms for you guys. This right here is negative m squared plus 20 equal to 0. And in another word, 20 is equal to m squared after I add this on both sides. And of course, we can take the square roots on both sides. And don't forget to put a plus minus to a number. So we are saying m is equal to plus or minus square root of 20. And we know square root of 20 is the same as saying square root of 4 times square root of 5. Square root of 2, right? Square root of 4 is a regular 2, so put down 2. And then we have the square root of 5. Okay, shall we have the plus or shall we have the minus or shall we do both? Well, let's look at, I want the x to be positive. If x is just positive, you know this is positive plus a positive. So all the y values here should be positive. Namely, the m shall also be as positive as well, right? Now, let's get rid of the negatives right here. We just want to have the positive version of the 2 square root of 5. Guess what? We are done. M is equal to positive 2 square root of 5, right? So just use some vertex formulas and some algebra, we can still achieve this. Now, I know this is the moment that we have been waiting for. Here is the calculus solution. I am going to write this down again. Y is equal to x, and I'll put this down as plus 5. This is x to the negative 1 power. And now let's talk about derivative. So differentiate this, we get y prime is equal to 1, and then bring this to the front, so we have negative, and this is 5, and subtract 1, right? This is the power rule. So we have x to the negative 2. And we are going to set the derivative equal to 0 for the critical value. And this is going to be 1 minus 5 over x squared equal to 0. And move this to the other side, we get 1 is equal to 5 over x squared. Multiply x squared on both sides, we get x squared is equal to 5. And then of course, once again, do the square root. Don't forget the plus minus. Cancel this out. This is x equal to, well, we don't care about negative square root 5 because x has to be positive. So we'll get rid of this. So we just want to have the positive version of the square root of 5. Is this going to give us a minimum or maximum? That's confirmed. So this is the first derivative test, right? Here is the number line, and then we have the y prime, right? And we are looking at square root of 5 right here. This is going to give us y prime to be 0. And by the way, we don't care about anything less than 0. Now, we have to plug in a number in between of 0 and square root of 5. This is bigger than 2 because this is bigger than square root of 4. So you can plug in 1. And let me just do that for you guys. If you say plugging x is equal to 1, plugging into the derivative, right? This form or that form. Maybe this is easier. So let's do this right here. This is going to give us 1 minus 5 over 1 square, right? And we can do this real quick. This is 1 minus 5, which is going to give us negative derivative. And then pick a number bigger than square root of 5. For simplicity purpose, let's put down, let's say 3, for example. And when you have that, this is just a test value. Let's do 1 minus 5 over 3 square. This is 1 minus 5 over 9. You get positive 4 over 9. So this is going to give us positive derivative. So what that means is that the y, right, the graph, it's going to be decreasing and then stops right here at that moment when x is equal to square root of 5 and then start to increasing, right? So the idea is that it goes down and stops and then it goes up. So that means this right here, it's going to be a minimum at x is equal to square root of 5. And now, when we know this is the number that we care, we just have to plug in this. For that, this is the minimum at x is equal to square root of 5. Now, the minimum y value, let me indicate that this is the minimum y value. It's just that I plug in x is equal to square root of 5 into there. So we have y equal square root of 5 plus 5 on the top over square root of 5. All right? Okay, so this is square root of 5. No problem on that. And right here, let's just go ahead and do this if you would like. Not just like a good old days. We're still doing some algebra sometimes. This is plus 5 square root of 5 over, down the bottom we have 5, right? And then you cancel this out. And you see, this is square root of 5 plus square root of 5. Well, at the end, we see that we have 2 of them. So that's 2 square root of 5. And we are done. All right? Anyway, that's it. And let me know which method do you guys like more. And of course, let me just give a shout out to my girlfriend. I got this from her. Right? And then I love it a lot. I love it so much, to be honest. Yes. And thank you so much, Jia Jia.